All right. So welcome everybody. Thank you for those who are joining and start to join. And if you are watching us on Facebook, that's awesome. And thank you so much. We have here Jose and Leila, which are from Robolink, our big partners. Thank you guys for being here and talking to us about this amazing tool and how it can transform actually smart transportation for education. And then of course we have Amy George, which is our K-12 account manager. Amy, thank you so much for being here, of course, and let's just get this started.
Thanks everyone for joining. This is our Gear Up for Back to School with Smart Transportation webinar. Like Maria mentioned, we have Jose here and Leila as well from Robolink. Some of our great partners that we have for this concept for the K through 12 schools. We're going to go through a little bit about Robot Lab. I'll introduce the speakers and talk about Robot Lab in a nutshell. Some of our areas of expertise, and then we will do the introduction for CoDrone EDU and Zoomy, and then following with some Q&A. My name is Amy George. I've been working with Robot Lab for about 3 years now, specializing in K-12 schools in the US and around the world. I've implemented several AI labs in the US in schools. And in 2021 helped launch the VR Expeditions 2.0 VR app. I'm very excited about that. A little bit about Robot Lab. We've been around since 2011. Our headquarters are in San Francisco, California, and we are the leaders in robotic solutions, serving about 32,000 customers worldwide. And we are present in multiple industries, not just education, but also hospitality, banking, retail, corporate, government, and healthcare, offering consulting, integration, deployment, support, and repair services. So that's kind of what sets us apart from other companies, is we also repair products. We do on-site installation support throughout and integration with your locations. We have some partners throughout the years in award-winning programs. And some of our major accomplishments are we're the sole distributors of the Now and Pepper robots in the North American, South American regions. We're the creators of VR Expeditions 2.0, a replacement for Google Expeditions VR platform. We've successfully installed multiple AI and esports labs at multiple educational locations. And we recently expanded to franchising for our businesses. So I'm going to introduce you now to Jose Mercado. He's an account executive at Robolink. He has a passion for drones, and his time at Robot Lab, he's dedicated his time to helping schools and integrate educational drones into schools across the US. Jose's main goal is to prepare schools for the next generation of learners, while also facilitating a fun and engaging environment. Go ahead, Jose, take it away.
Hi, everyone. I'm Jose. I work at Robolink. I'm going to be telling you guys a little bit more about our CoDrone EDU. So speaking of smart transportation, this is a CoDrone EDU. It has 7 sensors. All of them are completely programmable. Our drone is also approved for the aerial drone competition. If you guys are familiar with Vex Robotics, the REC Foundation runs those Vex Robotics competitions, and now they are running a similar version to it called the aerial drone competition. And our drone makes up about 90% of the drones in that competition. Also, a little bit more about the aerial drone competition. Last year, there were over 90 teams and 90 events across the United States and over 1,000 teams. So it's continuously growing, and our drone is, I would say, the face of the competition. Next slide. So now, since we're speaking about education being in a classroom, the CoDrone EDU was designed for in-class use. So with that being said, if you can see the GIFs, it's a little choppy, but the CoDrone EDU has a very flexible frame. The reasoning behind that is that it does a good job at taking hits, either from a wall or running into a person. But what the frame does really well is that it protects the motors, the propellers, and then all the components on the inside. Great thing about this too is that since it is built for a classroom and for students to use, we're going to assume that every once in a while there's going to be a part that either breaks because of poor care, but you can buy all the parts individually, and you don't have to go out and buy a whole new drone. So yeah, next slide. So now I want to talk a little bit more about the connectivity. I'm not sure how many of you guys have experienced or used drones in the past, but connecting your drone to a controller or to your computer can be a little bit challenging, and then the signal might not be the greatest. So we've solved that. The way we did that is by using radio frequency. A lot of other drones will use either Bluetooth or Wi-Fi to connect their drones to their controllers. We use radio frequency. What that means is that when I connect my controller to my drone, it creates a one-to-one pairing. That means that, for example, in this GIF, we stress tested 15 drones all flying at the same time in a classroom, and there were no connectivity issues. So that means you're just not going to have a lot of one drone connecting to another controller or disconnecting as another drone passes by. And it's great for classroom settings as well as competition settings. So next slide. So now I'm going to talk about the sensors. So accelerometer, gyroscope, barometer, and maybe even optical flow. Those are some sensors that you're going to get in other drones of this category. What sets us apart is our front range, bottom range, and color sensor. So the front range sensor really allows for students to get creative and maybe create their own obstacles. What I see a lot of teachers doing is that they will create a maze from tables or chairs in their classroom, like for a day or like a week, and they will have the students use that front range sensor, bottom range sensor to maneuver through that maze and kind of just have fun while teaching the kids how to program. Also, our bottom range sensor just gives the students another way of measuring the height of where the drone is at, instead of just having to use that barometer. Also, the color sensor, it's a lot of fun. You don't even have to fly the drone to fly it. One of the programs that we use is we put the drone on a landing pad, and then the drone itself will change to that color. But yeah, so that's all I have to say for the sensors. Next slide. Okay. So now this is our base camp. You can also call it the lesson portal. So right here, I just want to point out that you don't have to register or log in. It's just an option if you want to see what lesson you kind of did last. But our base camp and lessons, all of our curriculum is on here. It is completely free to use. You guys can go on learn.robolink.com and gain access to all of the CodeZone EDU lesson plans, Mini, Zoomy, all of our products. So usually when you click on the CodeZone EDU, you're going to have two options, what type of programming you want to do. So you can either do Blockly or you can do Python, and then all the curriculum will be there, step-by-step, beginner, intermediate, and advanced. And great thing about our lessons too is that we don't just want to give the teachers a lesson. We also create lesson plans for all of our lessons, and we make sure to write all the standards that are aligned with that lesson. So we try to put as minimal effort into implementing drones into a classroom. So the teacher just has to focus on facilitating that class and following that lesson plan, and then adding stuff if they choose to add stuff to the lesson. But next slide. Okay, so like I mentioned, we have two programming languages at the moment. So we have Blockly and Python. So Blockly, when you go to our website, just look up Blockly at robolink.com. You can use it on Mac, Windows, and Chromebook. There is no installation required. Great thing about Blockly is that if you're a beginner, this is kind of where you want to start. It's a lot like using kind of Legos, but teaches you like the basics of flying a drone. And then you can move from junior to senior. Once you kind of master that, you can move on over to Python. So right now, Python you can use on Mac and Windows. It's currently not compatible with Chromebook simply because you have to download Python and PyCharm in order to use it, and you can't do that on Chromebooks. Currently, we are working on a web-based version. Should be out fairly soon. We can speak on that a little bit later. Layla knows a little bit more about that. But yeah, so should be out fairly soon. I wouldn't say fairly soon. So it's not a huge issue or a lifetime away. But yeah, so in our Blockly as well, you can, I'm not showing you guys my screen right now, but in our Blockly, you can see all of the sensors live. You have access to all the curriculum right then and there. And then you also have access to a Python, approximate Python code. So once a student or the teacher decides they want to move over to Python from Blockly, they don't have to start off on a blank page. They have an approximate code for that program that they're trying to run, and then they can just transfer that over to Python. But yeah, next slide. So with the Codejourney EDU, what comes in the box is the Codejourney EDU itself, the smart controller, 2 batteries, a charging station, extra propellers, landing pads, as well as a quick start guide. The price for this is $214.99. Great thing about this package of one Codejourney EDU is that it comes with everything you need and a little extra. It comes with an extra battery, extra set of propellers, as well as a charging station, and most importantly, that smart controller. A lot of times you'll find that drone companies will sell you the drone itself, and then in order to cut back on costs, they're not going to sell you the smart controller. You either have to use your phone or computer, but we have that all included. So once you get it out of the box, you can just start flying. But yeah, that is it for this slide.
Thank you so much, Jose. That's amazing introduction to Codejourney EDU. I think it can be implemented in a lot of different classrooms, so I really appreciate you. So now we have your colleague here, Layla Firestone. Layla started at RoboLink in 2018 as an after-school programming and robotics instructor. So now she's been helping the development team that works on the software and content for Codejourney EDU. Layla enjoys building creative, engaging curriculum and is passionate about sharing her passion for engineering to students all over the world. I've seen her do demos before. She is a wizard with the Zoomy car, so I'm really happy to have you here. Thank you so much, Layla.
Thank you, Amy. So I'm going to be talking about Zoomy today, which is this little robot car right here. We call Zoomy the car that learns as you learn, because with Zoomy, you'll be able to learn artificial intelligence, and especially with the application to smart transportation. There's a direct tie-in to self-driving cars, technology that's helping automate the roads and make our cities safer. So hopefully with this classroom tool, students will be able to explore all of those topics. So next slide, please. So I'm going to do an overview of Zoomy. So Zoomy is primarily designed for ages 10 and up, and it's programmable in both Blockly and Python. So similar to Codejourney EDU, those are the 2 programming languages that we focus on. So it's a buildable self-driving car kit, which I'll show you in a later slide, but everything that comes in the kit is disassembled. So you get to actually build your self-driving car and then program it. It's also an approachable tool to teach artificial intelligence concepts. I'll be talking more about all the sensors that are on Zoomy, but it's definitely very small. It fits in your hand. It's not something that's going to be really difficult to set up. So it makes learning AI very approachable. And also Zoomy is really cute as well. There's multiple sensors for autonomous navigation, which I'll cover, but you'll have some IR sensors for obstacle avoidance. There's some on the bottom for line following, gyroscopes, etc. So students will be able to use all of these to put together programs that can navigate cities or their own city, DIY city that they want to build in the classroom. There's no software installation needed for Zoomy, so everything actually runs directly on board. So there's actually a computer on here, runs on a Raspberry Pi, so there's no need to install anything, you just need a browser. There's a camera in front for image classification and processing, so they'll be able to use the camera to take pictures and learn the basics of image processing to build artificial intelligence models. And ultimately, Zoomy prepares students for the future. So AI is definitely making a comeback right now with the emergence of lots of AI tools, as you've probably seen. So it's definitely really important at this stage for students to be comfortable with it and understand this technology to be able to adequately use it in the future. Next slide. So as I mentioned before, it's buildable, and this is really important for learning kind of how things work from the inside out. So maybe with some other robots, you can't actually, literally open the hood and see what's inside, but with Zoomy you can. So that really helps generate an understanding of how robotics works, just engineering, building in general, how circuit boards and how everything's connected together to actually make what you see on the surface as like a self-driving car or a robot. So students will be able to build everything together. Everything comes in the box. All the tools are there. So they'll be able to put it together and then turn it on and program it. Next slide. So what can Zoomy do? So there's various things you can do with Zoomy to introduce kind of AI concepts. So the first one, of course, is face detection. So Zoomy can detect faces using facial feature recognition. So we've loaded a model that can detect like noses, eyes, ears, and put it together and be able to detect a face. And then students will actually learn in a lesson how this works so that it doesn't become something that is, scary or something that is strange to students. We really want to unpack artificial intelligence. You can also drive a programmed route. So here's an example of like a little city that we built using the Zoomy Town mat. So that Zoomy is actually driving on a Zoomy Town mat, and you can put signs together and you can drive pre-programmed routes and use all the sensors to be able to navigate your environment. There's some road kind of like white, black and white lines across the bottom. So students can use the bottom IR sensor to maybe count them and see how far you've gone. You can create some sort of like distance function. You can use the camera. So there's not just one way to navigate the environment. And that's what we want to encourage with Zoomy. Third, Zoomy has like a little personality. So you can actually program the screen and there's a buzzer. So you can make little sounds. You can have different eyes and different screens. So you can really make Zoomy personalized. And for the students, that can be a really important part of like their AI journey is having their kit be able to react to the environment. Fourth, reading QR codes. So I have some QR codes here. And you can print QR codes with your own messages, and then you can have Zoomy detect them, and you can write a program to, let's say, tell Zoomy to go left or right if they see the left or right QR code. Similarly, we have a model loaded for sign detection. So here's a stop sign, and Zoomy actually can detect a stop sign. We have a block in Blockly that will detect it for you. And we also have a lesson that teaches you how that works. And finally, with all the sensors, you can also avoid obstacles. So you can use those front sensors to avoid obstacles, the back, the bottom as well for any sort of line following. So there's a multitude of sensors here that students can use to piece together a bigger picture of what AI can do, because obviously it's a combination of all of these things. Next slide. A quick overview of what's inside. So as I mentioned previously, everything comes in the box. There's nothing extra that you need to get Zoomy started. So the shell, the Raspberry Pi computer, the board, the microcontroller, the screwdriver, all the parts. And then in addition, there's these color cards that are actually included inside of the box. And this is so that you can use them to train Zoomy's camera. So there's actually an activity where we train Zoomy to recognize different color cards that you would just put right in front of Zoomy like that. And with these color cards, you'll be able to do different activities. So for example, the favorite one that we do is red light, green light. And we actually use this in one of our virtual competitions a few years ago online, where students actually had to train these models. And if they saw green, they could go. And if Zoomy saw red, they had to stop. So that's what these are for. Of course, the beauty of AI is you can use any colors you want, construction paper, extra materials, because the idea is that you can train Zoomy to recognize different colors. Next slide. A few of the specifications, there's 2 motors, the Raspberry Pi, there's a gyroscope, accelerometer, 6 IR sensors, the camera, and the screen. And those are all programmable, and you can read data from all of those sensors. It lasts about 40 minutes just without being connected, so on a full charge. And it takes about an hour to charge. However, it does last a fairly long time in the classroom because you can use Zoomy while it's plugged in. So I can actually take my cable, plug in Zoomy, and keep using Zoomy while I'm programming, or maybe working on some code, or maybe I'm debugging, or maybe I'm training my color sensor. So your Zoomy will most definitely last the whole class, especially if you're being mindful of just charging it when you're maybe training a model or doing something else and not driving. Next slide. For the programming languages, very similar to Quadrant EDU, again, Blockly and Python. Both modes of programming are accessible through Zoomy. So because there's no installation required and everything's running on the robot itself, you can actually use pretty much any device that has a Chrome browser and connection. So if you are a classroom with a Chromebook, or maybe you only have iPads, this is actually going to be a pretty good option because you can access Zoomy's dashboard through a Chrome browser. So in the next slide, please, I'll show all of the specification requirements. So mobile devices work, desktop computers, laptop computers. As long as it has a Chrome browser and you can connect to a Wi-Fi network, that device will work with Zoomy. So Zoomy will actually generate its own Wi-Fi network, and that's how you connect to it. So next slide. There's also some optional accessories that will really hit home to the idea of smart transportation. So the Zoomy mat is basically a really big map that looks like a city. There's different locations you can drive through. There's different blocks. There's even a bridge that you have to kind of navigate through. It is the size of an FLL field exactly. So if you have a table already set up for like FLL in your school, you can place this right inside and it will fit perfectly. There's also some activity cards that you can use to kind of practice these ideas relating to automation and self-driving. And then the driving school mat, which is a smaller version that encompasses lots of different topics that I just talked about. So they'll have to detect a stop sign, drive, program some U-turns, program some zigzags, line following, and QR detection. So this is kind of like a very goal-oriented way to do like a city navigation challenge. And I believe that's it for the overview on the products on our end.
Thank you
Awesome.
both so
Thank you,
much.
Leila. Yes. Jose, we're going to do like a little drone demo, right?
Yeah, so I've set up a camera right here.
Yes, Amy, maybe you can stop sharing so we can have the full image.
Yes.
Thank you.
So right now can I share my screen really quick just to show the code?
Yes,
Yeah,
I
go ahead.
think you're able to, yeah.
So this is our Blockly right here. Like I mentioned, we have a junior and a senior level. Right now, I have already preloaded this code. So what it's going to do, the drone is going to take off. Then it's going to set pitch, which means that it's going to be going forward 15%. And then it's going to, what this does, it's going to be repeatedly checking that front range sensor. And then once it gets to about 50 centimeters, it's going to stop and then it's going to land. So that's what we're going to be doing. Now I'm going to stop sharing so you guys can see the screen. So here, and then run demo. There we go. All right, so right there, I would have to correct it. Let me just fix this really quick. It flew over the wall because
Okay.
yeah, but
But
let me
we
do
couldn't
this
see it, don't worry. We see it like going that way. So that's awesome.
No, I think
Yeah.
that's actually really important too,
Yeah.
because it makes the students, have to fix their errors in the code or fix the
Right.
timing or the level of height. I think that's important with kind of project-based learning, is it's not a yes or no thing, it's experiential. So that I think that's really important for students to understand that as well.
Yes, and Jose, how long did it take you to create this little coding that you just did? Just so roughly in average, we can know how long students might take to do that.
Oh, so this code, I do this one a lot just to show off that front range sensor, because the front range sensor is the one that people really like, especially because you can use it to go through mazes, text something,
Okay.
and then you can maneuver around it. But I don't know, probably like 5 to 10 minutes,
Cool. That's awesome.
depending how familiar you are with programming on
Mhm.
Blockly. But yeah, so before we even started this, you noticed that me and Layla were kind of talking about the drone, and we had to kind of fix some of the issues, not even issues, but we had to trim it so then it was going straight. And
Mm.
then there's just a lot of factors into it. It's not like it's going to go forward and then 100% of the time it's going to do the same thing. If there's like wind or you didn't take care of a motor, there's hair in a motor, you have to make sure you clear that out and like get it ready for flight.
Okay, cool. No, this is awesome. And I think in the meantime, if you want to fix it, we can go with the questions because we do have a lot of questions and I kind of want to go with them right now. And
Yeah.
then, so the first question we have is from Andrea, and I think it's for you guys, you both. It says, is there any training available for Codron and Sumi?
Yeah, so we do virtual professional development. We have 2 hour, 4 hour, 6 hour, and then it can just go up. For a 2 hour session, I believe I think it's $400.
Okay.
So $399.99. But yeah, it takes you from getting it out of the box to kind of just learning how to handle a class with either drones or the Zoomy, and then it teaches you how to program all the sensors and how to just use it on a day-to-day basis.
Cool. And for Sumi will be the same, right? Layla, I think you guys have training is the same one. Cool. So the next question we have is from Katie. And she's asking, Jose, how long does the battery for Codron last for a class of 45 minutes?
Yeah. So if you're so the battery itself, let's say you're flying it continuously, it'll fly for 8 minutes. If you're programming a class of 45 minutes, you're going to be programming, you're not going to be flying it the whole time.
Mhm.
You'll probably go through 2 batteries, I would say.
Mhm.
There is a lot of downtime when you're programming. So I'd say like you'd get through 2 batteries in that 45-minute time range. Yeah, 2 batteries, which comes in the kit itself. That's just if you're going through the curriculum.
Okay. We just got another one from Lisa. To purchase, do we have to go through RobotLab or RoboLink? Amy, I think that's to you.
Yeah, I'll post my email address on the screen after his demo. You could go reach out to Robot Lab and myself, and I will provide a quote for you. However, we still have a ton of resources with Layla and Jose. If we need any additional questions or anything that I wouldn't be able to answer, I can always facilitate that, make sure that your answers get taken care of.
Yes. Thank you for your questions, guys. We have another one. Andrea is asking, how often is the base camp for Codron updated? This is from Andrea, and I think it's for Jose. Mhm.
That's more of a Layla question.
Oh, Layla. Go ahead, Layla.
So we're currently, in terms of content, we're usually going through always adjusting things if things don't look right. Whenever we get feedback from teachers as well, and even aerial drone competition coaches, we always take that to heart, and we like to make sure that we keep that up to date based on any questions that we have. So I would say we look at it pretty frequently. We're working on doing like a bigger, I guess, redesign coming up in the next year where we're going to add a lot more content. So stay tuned for that.
Awesome. And Layla, we have another question from you, and this is from Maya. Layla, how many Zumis will be recommended for an elementary classroom with 25 students? Sorry.
25. I would probably say, so I think we have classroom sets that usually come in sets of 10 and 20. So I think if you're going to have 25 students, you can always pair up with the Zoomies as well. So that way you don't have like a lot of them driving around in the classroom. But in terms of connection, if it's a concern about connection, this is a Wi-Fi connection. It's 1-to-1. Every Zoomie has like an ID So there shouldn't be any interference if you wanted them all to have their own Zoomy. So I would say you can do 1 per 2. So I guess getting probably maybe 14. And then if you want to have them in groups of 3 as well. But I think recommending partners is good, especially for there's a lot of like data collection. So you might need someone to hold this, the card while someone's
Right.
moving. So I think doing partners, especially for elementary, would be a good idea.
And we have the same question for you, Jose. Sarah is asking, it is recommended to have 1 co-drone per group of how many students?
So what we recommend is if you have 8 to 10 students, you can do 1 co-drone EDU per student, 1 kit per student. If you have more than 10 students or more than 20, we either recommend that you pair up, or if you have more than 20, we definitely recommend that you pair up. So 2 students per drone. If you have 10 to 20, somewhere around there, you can either do 1-to-1 or 2-to-1. So the reasoning behind that 2-to-1 over 20 students is that even though you can have like 10, 15 drones all flying in a classroom, it's not really the safest thing or the smartest thing. You don't want to have more than 8 to 10 drones flying at the same time in a classroom. Probably no matter how big a classroom is.
Yep.
In a gym, you can get away with that, but in a classroom, you probably can't, especially because a lot of teachers set up half of the classroom. They put all the desks and chairs in one side of the classroom, and then the other side, they use it as a flying area.
Yeah,
But
that makes sense. Yeah, totally.
Yeah.
Thank you, Jose. We have from Pablo is asking, can I use co-drone and Zoomy for a higher education classroom?
Yes, so I can answer that one. I've actually done professional development sessions with college professors before. So we definitely have used it even in high school and higher education. We do see just as like an introductory programming course, and especially with Zoomy because it uses a Raspberry Pi, it's a really great introduction to just Raspberry Pis and circuits and actually building things. So I would definitely say yes. It's not just limited to, kids. I mean, I still have a lot of fun with the drone, so you can definitely learn real life industry, just Python programming skills with both of these products because they both can be programmed in Python.
Yes, and I think these tools also prepare the students, before going to high school to get like a very, very close knowledge of what it's going to be, in the future. We have another one from Lisa. As content is updated for Zoomy and co-drone, is it necessary to purchase new equipment, or can updates be installed to current devices without purchasing new ones each time?
I can also take that one. So in terms of content, so the content is just on our learning platform. So it's on, if you go to, I think it's the Basecamp learning that Jose mentioned, that's where we host all of our lessons. So if there's any updates there, they shouldn't affect, anything on the drone. Zoomy will be downloaded automatically if there is an update. If you're connecting Zoomy to the internet, it will let you know that there's some new content and you can download that as well. Co-drone, there might be firmware updates, so that means updates with the actual hardware. So if that's the case, you'll also know if you go just checking on I think we're going to have on our block programming like a little icon that'll let you know, hey, there's been an update to the hardware, and then you'll be able to do that as well. So there's no need to actually get new hardware. Everything, they'll just be updates that you can do for free.
Cool. Thank you so much, Leila. And we have one question for you from Julie. Leila, how easy is to program Zoomy if I don't have coding experience?
Sure. I can, I could open Blockly if time allows. But
Yeah, of course.
oh, sure. I can probably do that then. Just
Yeah.
so I can
Yeah,
show.
and that's a great question too. Sometimes teachers don't feel comfortable like programming or coding, or they might think it's very hard to do it, but in reality, it's something really quick and they can learn with students as well, so that's good. We have this question, so.
Yeah, so thanks for asking that question. So this is actually the dashboard that I just opened up. So I'm actually connected to Zoomy. So if you want to learn how to program Zoomy, if you've never programmed before, then we do have our lessons. They're just going to load up 1 second. So here are all of our lessons and they're all on Zoomy and it'll walk you through everything. So this is like the Python. So if you want to learn how to do Python with driving lessons, we have instructions here on the side that will load up, and you have your coding platform here, and you will just follow along with the lessons. I don't think I loaded it today. So just give it one moment. If I'm doing a call at the same time, sometimes my computer likes to slow down a little bit. So let me open the block. Oh, there we go. So it's going to be very simple. And I think because I reloaded it, I messed with it. So let me reload this page so that you can see the stop sign detection with Blockly. So we do have lessons on the Basecamp, and it's just like dragging and dropping. So it's actually very similar to the Blockly that you just saw with Jose.
Okay.
So let me get that loaded up. I think I had it open for a very long time, and then I accidentally stopped the
Let's
page.
do one
So
more try. It's fine.
let me get that loaded up. All right, there we go. So while that's loading, just to kind of answer your question,
Yeah.
it is just very easy. I mean, it's meant for students 10 and up. So like you'll have a block that's like drive forward or drive backward, and there we go. So I have it reloaded now. So for example, here I'm starting the camera. I'm going to take a picture and I'm going to see if there's a stop sign. And then we have lessons for all of these. And then, for example, if you want to drive, I just want to, let's say, go forward, and maybe I want to make a happy sound because I moved. And then after that, maybe I want to check a sensor so I can get the IR, I can get the angles, get the battery, and all of that. So it's very similar to kind of get started. And then it's really exciting once you run your code, because then Zoomy will start driving around.
Oh, that's awesome. Thank you so much, Layla. And it's easy that you tell us that it's also curriculum available to guide teachers on how to do it as well. That's awesome. I don't know if you guys have more comments on your products, and if you have more questions. I don't think we have more questions. I think we're done with the questions. Yeah, we have. But if you, I don't know, you guys talk about the competition, the Euro competition. Jose, you talk about that Code Drone competition. So can you maybe tell us, is there some way we can watch it? Is there how does it work? So maybe people that want to see it are interested on it.
Yes, so the RC Foundation runs the aerial drone competition. Every year they come out with new fields, like new field setups, and there's two parts to it. So there's the autonomous part and then the co-piloting part. For the autonomous part, you already have the measurements of the field beforehand. So once you get into that competition, you and your team will just set your drone down and then use the code that you've been working on either for a month or 2 months or a week. But yeah, so that's the autonomous part. You go through the obstacles and try to get as many points as possible. Then there's the co-piloting part. That part requires a lot of teamwork. And it's a part where I think they have the most fun, kind of like a reward. But so for the co-piloting part, there's usually a pilot. The pilot is flying, and then there will be a blackout zone. So the co-pilot will have visible sight of that blackout zone and will have to direct either with hand gestures or with words, tell the pilot how to maneuver through that blackout zone and how to land where they can get the most points. But yeah, that's the aerial drone competition. Over 90 events this year, and then it's kind of expected to grow. And the REC Foundation, if you do live in a remote area, you can always get in contact with them, and they are usually more than glad to help you try to start a competition in your area or at your school.
Oh, that's awesome. That's another encouragement for people to use the drones. Guys, thank you so much for your time. See, if you guys have questions, maybe you don't have it now, but maybe in the future, you can definitely text Amy, and she might definitely, you know, point you to the right person and answer your questions, whatever you have. And then thank you, Jose. Thank you so much, Layla. We really love your products. We're so proud of this partnership, you know, with RoboLab, because that's exactly what we do. And we just want to show teachers the best tools out there that they can use in their classroom. So thank you so much, guys, and thank you for joining. And then I think we'll see you in the next opportunity.
Thanks, Amy, Maria, and thanks, everyone.
Thank you.
guys.
Thank you, guys. Have a
Thank you.
wonderful rest of your day. And thank you for joining, guys. Bye-bye.
Bye.